Ladies and gentlemen, it's final exam time, and that means we got to go through all the units unit by unit. First one, we're going to start off with logarithms and exponential functions. If I am given a logarithm and I want to rewrite it as an exponential function, I can do that, and then sometimes I can solve for x. So this is the same question. Bonus, one less to do. All right. Now, if it says rewrite it as an exponent, this is the base of the logarithm, so that's the base of the exponent, and it's 9 to the x equals 3. You can do this a couple different ways. One way to do it is to rewrite this as 3 squared. So 3 squared, and then that x is going to be up there as well. Now I can say, oh, 3 to the 2x equals 3 to the first. So when does 2x equal 1? That's x equals 1/2. Another way you could think about this is saying 9 to the 1/2 is the same as the square root of 9, and that equals 3. So that's 1/2 either way you look at it. Second problem, log base 5 of 1 is x, so 5 to the x is 1. 5 to the what power gives you 1? That would be the 0 power. So the second one is x equals 0. Next up, find the inverse of each function. The first thing you need to do here is flip x and y. So when I flip x and y, now I've got that. Now my goal to get the inverse is to get y by itself. So first thing, before I do any sort of logarithm, I want to isolate this exponent. I'm going to subtract 5. So now I have x minus 5 is 3 to the y minus 2. Now, if I want to undo taking an exponent with base 3, I'm going to take the base 3 logarithm of both sides. And when you take the base 3 logarithm of an exponent with base 3, then you just get the exponent, 3 minus 2, or y minus 2. Now I need to get y by itself, so I'm going to add 2, and I could write this a couple different ways. Let's say 2 plus the logarithm with a base of 3 of x minus 5 equals y. And that's my answer. Same game here, flip x and y. This is x, this is my y, so now it's x equals log base 10 if it doesn't have a base, y minus 3 plus 3. Now I need to get x or get y by itself, so subtract 3 from both sides, the log of y minus 3. And now I can rewrite this as an exponent. This is log with an implied base of 10. So now I'm going to say 10 to the x minus 3 equals y minus 3. I'm rewriting the logarithm as an exponent, and then when I add 3 to both sides, now I have 10 to the x minus 3 plus 3, and that is my inverse function. Next up, expand logarithm completely. So when you're expanding logarithms, you need to know a few rules. One of them is that you can expand multiplication into addition. So this is log base 2 of x to the 4th plus log base 2 of y to the 5th plus log base 2 of z. So first thing, everywhere you see multiplication, you can expand that. And that's actually the same rule here. If this is x to the 4th, I can bring that down here and now say this is 4 times the log base 2 of x plus 5 times the log base 2 of y plus the log base 2 of z, and now that's completely expanded. You can also expand division into subtraction, but before I do that, I'm going to just simplify this to 1 over x squared. Now that's like saying the natural log of 1 divided by x squared. I can rewrite that as the natural log of x to the negative second, and then say this is negative 2 natural log of x. There's other ways to get to that, but if I see an exponent in there, I'm going to simplify that and maybe make it a little bit faster. Condensing is the same process, but going backwards. First thing, I'm going to put these exponents back in, so now it's log x to the 3rd minus the log of 3 squared, which I can rewrite as log x to the 3rd minus the log of 9. Now, if you see division, or if you see subtraction, you can put it back together with division. This is log of x cubed over 9. So now I've got that one condensed. Let's do another one. This is the natural log of 16 to the 1/2 plus the natural log of x cubed. Well, 16 to the 1/2, again, that's the square root of 16, which is 4, plus the natural log of x cubed. And now we've expanded into addition. That means we can condense this into a single logarithm, and that will be 4x cubed. So the natural log of 4x cubed, and we're moving right along. Next up, evaluate by using the change of base formula. So the change of base formula says I can take the log of 5 and divide by the log of 3, and that's the same as the base 3 log of 5. So when you actually type that in your calculator now, you can just use, you can use any log you want. You can use log base 10, or you could even use natural log. The log of 5 divided by the log of 3 is 1.46. And if you don't believe me, I'll just do it real quick. The natural log of 5 divided by the natural log of 3, and I get 1.464. So this is 1.464. And now I can do the same thing here. The log of 64 divided by the log of 2. And you should be able to do this one in your head. 2 to the what power is 64. But just to say we did it, oops, log of 64 divided by the log of 2 should be 6. Yep, 6. Alright, solving equations, the first thing you need to do is isolate the exponent or the logarithm. So let's isolate that e to the x. I'm going to subtract 5, so 20 minus 5 is 15. I'm going to divide both sides by 2. Now I have e to the x equals 7.5. Now, to undo this base e exponent, I need to do a base e logarithm. A base e logarithm, we don't write log base e, that is the natural log. So we'll just say, take the natural log of both sides, and that gets you the exponent, and now it's the natural log of 7.5. So the natural log of 7.5 is about 2.01. Did this earlier, let's make sure. The natural log of 7.5. About 2.01, I think. Yep, 2.015. So there we go. This one says, take the log of 5 and the log of 3x minus 4. What if I just don't take the log? So I have 5 equals 3x minus 4. If you're taking the log of both sides, what if you just don't take the log of both sides? And now I add, and I get 9 equals 3x, so x equals 3. The only thing you need to be careful of is you make sure that when you plug 3 in there, you don't get a negative number, because you can't take the log of a negative number or 0. So you just got to make sure that that is actually a solution and not an extraneous solution. One more like this, isolate the logarithm first, and then we'll rewrite it as an exponent. So now it's the log base 3 of 2x equals 2. And now I need to rewrite this as an exponent. So that would be 3 squared equals 2x, which is 9. And then you divide both sides by 2, and you get x equals 4.5. One more to go. If your car loses 12% of its value, then that means it retains 88%, because 100% minus 12% is 88%. So if it's keeping 88% of its value, how many years can you own it while it's worth more than $10,000? Well, let's see if we can figure out its value over time. So we know that it starts at $24,000, and then it's going to be 88% of the previous year. So let's say 0.88 times x. After 1 year, it'll be 88% of its value. After 2 years, 3 years, etc. So what I can do now is I can figure out the value of any given year. I'm actually going to use my calculator for this, because it'll give me all the years. 24,000 times 0.88 to the x. And now when I go to my table, I can see the value after all these years. After 1 year, it'll be worth about 21,000. After 2 years, it's 18,000. After 3 years, it's 16. Let's see, when does it get to 10? 6 years, it's still worth over 10,000. But after 7 years, it's no longer worth 10,000. So I would say that somewhere between the 6th and 7th year, the car will be worth less than $10,000. How many years can you definitely keep it? You can keep it for 6 years, and it'll be worth more than $10,000. And that's it for Unit 1.